to deploy a Spring Boot microservice to production using JHipster, which is a code generator that I have created, and we will deploy this microservice to Microsoft Azure using a new service called Azure Spring Cloud, on which I am working on currently. So let's get started. Let's first have a quick overview of what JHipster is. So JHipster is an open source code generator. It is totally free. We don't have an enterprise version. We don't try to sell you anything. We've got today more than 160,000 installations just last month. We've got 15,000 GitHub stars and more than 500 contributors. So as you can imagine, we've got a lot of users and a lot of contributors because it's, of course, an awesome project. As it's all open source and free, we will be more than happy to have you as either a user or even better as a contributor. So if you want to join us, don't hesitate to come to our GitHub page right here and you can start coding with us. Now, let's just use it as a normal person. So there are several ways to use JHipster. The most common one is to use the command line. So if I go here, let's create a new directory and run JHipster here. Here, JHipster is just an executable program that will ask us questions. This is a normal usage of JHipster. It can be pretty advanced because you can improve JHipster by a number of ways. We've got lots of flags, options, modules that you can add. Let me put this a little bit bigger. And that's what most people would do. For today, we are going to do something even easier. We have on JHipster an online version of the tool. So it is going to be basically the same thing as what we just saw here on the command line, but this time it's with an online application. So it's going to be easier for this demo. I would recommend that if you are just getting started. You have a few options which are missing, but it's in order to make it easier for you to get started. And then when you want to use the full JHipster, well, then you will go to the command line, of course. So I'm going to generate an application in my GitHub repository. I'm going to call it also test. As we are going to do microservices, I'm going to select a microservice application. The difference with the monoliths is that we don't have a front end. We are not using Angular, React, or Vue for the front end, which is also something that JHipster can do for you. I'm going to keep everything by default, except a few things here. As we are going to use microservices, we want to use some discovery server or some configuration server. For those, we don't need anything now because I am going to deploy to Azure Spring Cloud, which provides everything for me. You can keep those options if you are a more advanced user, but for doing something simple, let's not use that at all. I'm going to keep the default database, which is MySQL, but just so you know, JHipster supports a huge number of databases, including most SQL databases, but also MongoDB, Cassandra, Couchbase, Neo4j. Yeah, I'm just going to keep the minimum. I'm also going to remove caching. We've got also support for different caches, like local caches with EHCache, distributed caches with Hazelcast, and also using like a Redis external cache. This works very well, for instance, with Microsoft Azure. I'm not going to use those because, once again, we've only got 20 minutes. But also, if you are a more advanced user, that's something you will need to check out. Then I'm going to keep everything by default and just generate my application on GitHub. I could have also downloaded it here as a zip file if I didn't want to use GitHub. This is generating my app in the cloud, and it is pushing it to GitHub. We'll just now need to go there. Here is my new GitHub repository. As you can see, it was generated right now. And I'm going to clone this. And let me remove my test directory and git clone that new directory. Here it is. Let's go inside it and open it up with an IDE. JHipster has generated some Java code for me, of course, based on Spring Boot. It has also generated for me my unit test, as well as a number of other files. First of all, it generated some configuration files and some documentation. So as you can see here, as soon as my IDE starts, I've got some documentation on what I can do. Like I can start my application using Maven. Here is the documentation for the version of JHipster that I have used. Everything is ready for me. You can see here also that, for example, my target repository is correctly configured. This is mostly because here we've got some configuration files that my IDE is understanding. So I can just start my app right away. Let's just click here on Start. My application will boot up, and I will have a fully running microservice based on Spring Boot. You can see here the Java files. So here is my application starting up. It is starting up with an embedded database, so that's why it takes a little bit of time. Usually it's 6 or 7 seconds. I can click here and have a look at my running microservice. So I've got my microservice running. It is based on Spring Boot. Let's have a look here at the main class. As you can see, it is based on Spring Boot, and we have generated here a full hierarchy of directories, which should be pretty usual for Spring Boot users. For example, I've got a config directory where I've got all my Spring Boot configurations, which are neatly separated in small files. So this is what JHipster generates for you. But also here we've got some domain directory, repository directory, service, and web directories. Those are the usual packages you will use with Spring Boot when you are doing an application. At the moment they are empty because we've just generated an empty application, so we've only got configuration files, but no business code yet. So my app is running, and indeed I would like now to create some business code and start working. First of all, just let me show you that we've got out reload working. So if I go here in my main class and type some code, like out reload is great. I just compile my code and my app will automatically reload, and well, I will be happy. Here it is. So out reload is great, and it took only 3 seconds to reload everything. So I can work right now very efficiently. My database is ready, my code is ready, everything is ready. But JHipster gives you more than that. It gives you what we call subgenerators. So a subgenerator is a way to improve your existing application. We've got more than 100 of them, so I'm just going to show you the most popular one, which is called the entity subgenerator. We've also got a web interface for that. What it does is, for example, let me take this one. What it does here is it can generate what we call entities. So an entity is basically a domain class in Java. Like here we've got a customer class. The customer has got a first name, a last name, an email, and a phone number. And what JHipster will generate for you is, first of all, the domain class, but also all the database code that you need to use that class, and also the repositories, the Spring MVC endpoint, and all the tests, all the unit tests to validate this. Here we've got several entities. JHipster is going to generate all of them at once. Let me just go here, say apply, and I'm going to apply this UML-like model to my test repository. This is going to generate a pull request on my repository, and I will be able to merge it, and I will have all my entities ready for me. Here is my pull request. Let me merge it. And now, just getting back here to my application, you can see I have nothing. Well, I've got only 2 base classes in my domain model, for example. I can just do git pull, and I'm going to have the new classes automatically arriving. And as I've got out reload running, I just need to click on compile, and my app will be up and running with all those new classes. You can see I've got also repositories and Spring MVC endpoints, which have arrived. If we go to the test repository directory, you can also see that we've got now some unit tests which appeared to validate what we had generated. I can easily run them by just clicking run the test here. So my app is updated, my tests are going to work. I'm going to let this run in the background just to show it works. Now I would like to see what we have generated. Is it really working? Do we really have our database running, and so on? So let's do something very easy. First of all, let's do a curl on our app. So I've got some API calls here on, for example, the customer domain object. So customers. Oh, sorry, I forgot the port. As you can see, our app is secured by default, and this is one of the philosophy of JHipster. Everything is production ready, so we have security which is out of the box. Also, you can see that we don't have the default error message from Spring Boot. We've got something which complies to an RFC, which gives you JSON error messages with so status, detail, and so on. And if you want to customize them, we, as always with JHipster, we give you some documentation to help you. You can just click on this link and have a description of what you add and how you can customize this error message. It's pretty easy, in fact. You've got a specific class to customize those classes. So we saw that our app, well, was running because we had an error message, but we were not logged in. Let me remove the security because it's going to be quicker than to authenticate. Here we've got, and also I can show you how JHipster configures everything for you. So here I've got some neat configuration files for Spring Boot, and I'm going here to a classical Spring security configuration, and I'm going to say permit all for all the API calls. And so now I'm going to be able to do my curl request again, and this time it will work because I've got outward running. So running, here it is. Something you might not notice is that I've got a lot of sample data arriving. That's another cool thing with JHipster. We generate out of the box the database files, but also some fake data. So you can have something realistic when you are developing. This fake data is available here in our resource files as some CSV data. So it's very easy to edit it and put probably some more real life test data. So as a developer, I've got everything here to work, my database, my sample data, my Spring Boot code, everything is ready for me. Now, as you could see, it was quite easy to generate that application and to improve it. Now let's push it to the cloud, and for that we are going to use Azure Spring Cloud. So I prepared a few things for us. So I generated a specific resource group, which is called Spring Live. So a resource group is just a logical grouping of resources in Microsoft Azure. So nothing really specific here. And inside that resource group, I created two resources. One is a database, because we're going to use a real life database this time, and then a Spring Cloud cluster. So I just generated them to gain some time now, but they are not configured at all. So let me just go and configure first database. I need to do two things. First of all, I need to give access to my database on the firewall, so my Spring Cloud cluster can access it. I'm also going to add my current IP address so I can access it from my local computer. And this should be done. So if we go to MySQL Workbench, I should be able to access it now. And we're going to see that it's totally empty. I've got like really nothing in my database. That's good. I'm going also to take the connection string here, because I will need that just afterwards. So Now I'm going to my Spring Cloud cluster. Here it is, Spring Live. My Spring Cloud cluster is currently empty. If I go to the apps menu item here, we can see I have no app running. Let me just go to my application. I would like to configure it to run in production using my new database. There are many ways to do that. I am going to do the easiest one, which I probably would not recommend in production. I'm going to use my application-prod.yaml configuration file, which is a very standard Spring Boot configuration file for the production profile. I'm going to put here my database URL. I'm going to say I want to use SSL also, because by default we don't use it because not everybody has got it, but of course you should use that in production. I'm going to put my username and my password. So once again, this is not a good thing to do. I'm going to explain why I'm doing it now and what you should do. So first of all, I do that now because I can explain it to you more easily, and also because it's the easiest way to go to production. Then it's not a good idea, because as soon as I commit that code, it will be available to everybody who has access to my GitHub repo, and it is public, so it's definitely not good. And I'm going to push that to production, and then we're going to see how we can improve that in different ways using Azure Spring Cloud. So to put my app to production, I'm going to use JHipster Azure Spring Cloud. So this is another JHipster subgenerator. The previous one that we saw was to create entities. This is another one, which is to push your application to the cloud. I'm going to execute it on the command line, and this is going to ask me a few questions to upload my app to the cloud. I'm just going to say yes to everything, and we're going to have a look at what happens. So what this is doing is that it scanned my configuration files. It saw the name of my cluster, the name of my app, and so on. And it's going to build my app locally, so on my machine, and it's going to push it to the cloud automatically. As my application did not exist yet in my cluster, it's going to create it. Then it's going to build it, push it, and everything will run automatically. It is going to modify my application in a couple of very small ways. It is going to add a new Maven profile for building my application and pushing it to Azure. And it's going to add a specific Spring Boot profile also, which will be specific to Azure. Those files, or those profiles are mostly for you to improve once they have been generated. The only important thing that you need to know is that for the Maven profile, we add a specific jar file for Azure Spring Cloud. So it is specific to Azure Spring Cloud, and it is used to connect our microservice to the discovery server and the configuration server, which are both secured. So I'm going to force everything, and let's go now to Azure Spring Cloud. We will let our application here be deployed, and let's have a look at Azure Spring Cloud, and we'll see it running at the end. So first of all, I had no application here. We have just created it with the command line. So if I refresh, you can see my application running. As you remember, that application was configured here in our Spring Boot configuration file, and we said it was not a good idea. You have a number of other options on Azure Spring Cloud to do that. You can go to your application and configure it here using environment variables. We also support service bindings. So service binding here is going to automatically configure your database, your MySQL database, in your application. So your application will be automatically configured to use the database without you doing anything. And a third option, you can use a configuration server. So a configuration server is specific to Spring Boot. It is running a Spring Boot configuration from a Git repository, and it is going to push that configuration to your microservices. So using that configuration server also is a good solution to externalize your sensitive data, like your database password, and push it to all your microservices without you doing anything inside your code. So my application getting deployed. Once it will be deployed, we will be able, you can see it's allocating my new app. Once it will be deployed, we will be also able to scale it. As you can see here, we can give it more CPU, more RAM, or even more instances. So you can scale it vertically or horizontally. And also you will be able to fully monitor your application. You've got full access to your logs, to your metrics, including Spring Boot and JVM metrics. And also you will have distributed tracing here. So you will have access to the performance of your HTTP request, even between your microservices. So you will have even a full map of your microservices if you have several of them. Here I've only got one, so it doesn't really make sense. My app is upgrading. It's going to run. One of the first things it will do is update my database. So if I go to my SQL Workbench, you remember that here I had, well, nothing, well, just a schema for MySQL, but nothing else. Let me refresh that. And as you can see, I've got the test database which arrived. If we go inside it, we've got here the table that belongs to the application that I have been developed. So for example, here we've got category, which is the same thing as the category that we had here. If I open this up again. So all of this has been created in my MySQL database. And my application is of course running because my application is the one which generated that schema. So if I go back here to my app, if I click on refresh, my app should be up. So that means in our discovery server in Eureka, it is seen as being running. I can click on my app and let me assign it a public endpoint so I can access it more easily. And once I've got the public endpoint, I will be able to do again a curl request to have access to my app. Let me do the curl request again. Let me prepare this. Okay, here is my public endpoint. Oh, copy pasting didn't work very well. Here it is. So this is also once again my curl request working. This time it's giving me an empty array because in my database, of course, I have no data at the moment. But as soon as I add some data, well then, that array will not be empty anymore. So I hope I have given you a good introduction on what JHipster and Azure Spring Cloud can do. Thank you.